Students, I think, would benefit from choosing SWOC because it gives them an opportunity to get involved at a more hands-on level earlier in their career. Students choosing to come to SWOC benefit from having opportunities at the freshman and sophomore level to get involved in research that can carry them forward in their career while still maintaining the same academic rigor as they would experience at a four-year institution. The day in the classroom in physics and engineering starts out as sort of a conversational approach to the material that we're looking at, whether it be solving rocket science problems, whether it be designing bridges, whether it be designing electrical circuit systems. It's usually a conversational approach that leads to a lot of questions. I always tell students if they're doing science well, they'll always leave science class with more questions than they got answers to begin with. And that's to drive the intellectual curiosity of the students. And that's what I try to do, making things interactive as possible and letting them foster that curiosity and develop those critical thinking and teamwork skills that they need to succeed as they go forward. You're dealing with a class in physics that's typically between 10 and 20 students. That gives you plenty of time to interact, ask questions. You get more direct responses from the instructor. And SWOC being a small enough school, there are instructors that you will see a number of times, so you get to develop sort of a rapport with your instructors and truly do become more like mentors than they do become teachers. The biggest thing it brings is a sense of opportunity. It gives us a chance to revisit how our curriculum works. It gives us a chance to incorporate new ideas, new equipment, and it also provides the students with ample opportunity for new projects and new developments in terms of research. The physics and engineering programs at Southwestern are a great way to begin your journey in a professional STEM career.
Going on over at the department with our physics and engineering department. We have some awesome student researchers they go by SPEAR, and they are working on a variety of different research projects looking for meteorites, asteroids, and we've got some high altitude balloons that we put up in the air and all kinds of fun stuff. Our PRISMS project, one of the most fun parts for me is we get to actually go out and connect with a lot of our K-12 educators around this area. And later on, you'll see a little bit of some of the recent things that we've done at one of the local schools. Also, like Dr. Coyner, I am one of our NASA Solar System ambassadors, and we are excited to have you here tonight. And I'm going to go ahead and give it to Dr. Coyner now, so he can tell you a little bit about tonight.
All right. Thank you, Kristen. All right. So welcome to our Physics and Astronomy lecture series, and congratulations, you picked the one of these that will be the least scientific talk we've had all year. But as it is, I wanted to do something special for March. I am the physics and engineering instructor and the associate professor of physics and engineering here at SWOC, and Crystal and I are often in charge of creating our own physics and engineering program and trying to connect with students at all ability levels from K-12 through community college to and following our students as they go on to the four-year institutions. And one of the things that particularly comes up and is a particular passion of mine because of a little bit of my backstory, which we'll get into, is I always want to try to find ways to connect to students that may have medical challenges or may have learning challenges that may have had them be told by people that they may not be able to pursue STEM education or STEM research. And my answer to that is anybody can do it. It's just a question of how much work that you want to put in. And that's a lot of what this talk is going to be about. Let's see if I can. So, why this talk on this particular day, on this particular month? Well, STEM education and research is challenging for everybody, but it can be accessible for everyone as well. There's many scientists that made world-changing discoveries that struggled with limitations and medical issues of their own, that made their contemporaries doubt their abilities, and students today have more options for how to handle things like that, but they also have some similar struggles. And I look at it from my perspective. Why did I do this now, and why did I do this particularly in March? I was born with cerebral palsy. I am, as I joke with my students, I am gravity challenged. They make me teach gravity every day, so I don't turn myself into my own example problem. But despite the fact that I have limitations that make it sometimes difficult for me balance-wise, I've still managed to succeed and make it through with a PhD in astrophysics, and I now try to share my story and my understanding of things with all types of students, and try to actually instill confidence and enthusiasm, and also spark inspiration in the next generation of scientists that will be taking over the mantle at some point. Another couple of reasons why we do it in March. March 14th, for the mathematicians, it's Pi Day. For the physicists, it's the anniversary of Einstein's birthday, and it's also a memorial of Stephen Hawking's unfortunate passing, and given his struggles with ALS for over half a century during his scientific career, Dr. Hawking was one of the people that I looked up to most as I was going through my physics studies. So that's part of the reason why we're here today. And the other reason we're here today is just to give kind of an idea of, I want to talk about historical achievements by famous scientists with disabilities, and then I also want to talk about advice for students as they go forward, and advice for us as educators and community members to support those that are looking at going into research and going into STEM education. And we'll talk about some of the things that we do as a program, and some of the things that we look forward to as we go on. So again, why me? I was science curious since I was small. My science origin story times itself with the last time Halley's Comet happened to fly in visible to Earth, which was about the time I was about 5.5 years old. But my mom was a scientist, and she was very interested in me getting to see this because it only happens once every 76.3 years. So that was the first experience I had with anything astronomy related. Was we made special trips to make sure that we went out to see Halley's Comet when it was visible. As I said, I was born with mild cerebral palsy. I didn't walk until I was 3. There were some doctors in some sort of my original care team that said I might not make it to 10 or might not make it to 20. For the record, I'm 42 and I'm fine. but it's still, when you hear things like you might have a limited amount of, might have a sort of a limited time, and they have kind of limited expectations for you, it can be kind of a downer. But one of the best things I had was I had a support system in terms of family, friends, educators that I ran into in my formative years when I was in K-12 school, and then when I was in college. I always had educators that were willing to push me along in the direction that I needed to go. And I feel like now that I've sort of come full circle, and now I am the one standing behind the lectern, it's my job to continue that and sort of push and sort of push and sort of motivate students that maybe facing challenges that they don't necessarily want to talk about, or challenges that they might find some of the stuff we do difficult, but they still want to do it. I am very cognizant of not telling a student that they can't achieve something. I will point out that it'll be difficult. I'll point out that there'll be extra work with it, but I'm not going to tell them they can't do it, because I'm not going to be that person. Because I've had a few people that have told me that before. There may be some funny stories in this talk, depending on how this talk goes. But more than anything, as I said, as I've worked with students and researchers with different challenges, I've seen what everybody's capable of. And sometimes if you get them past whatever roadblocks they happen to have, whether it be a fear of math, or whether it be trying to get adjusted to doing actual hands-on research that they may not have had experience with, once you clear the experience hurdle, then they become their own self-starters. You give them a project that they're truly interested in, and they will drive the conversation, and I can just sit back, relax, and let it go, and then chime in when they actually need help. But that's what I try to instill, and what I try to create in the students here, and what the kind of inspiration, the kind of drive that Crystal and I and the rest of the SPEAR team try to instill in our K-12 students when we go visit them. And we'll talk about, like I said, like Crystal said, some of the more recent adventures in the K-12 circles later on. So I have to start this with, if we're going to talk about science research and science education, what exactly makes a scientist? And I love this quote from one of my mentors, Dr. Jeff Goldstein, who actually did a talk for us at SWAC while we were in the COVID bubble about STEM education. And I love this quote because it's completely true in certain aspects. Scientists are toddlers that never fully grow up. The reason he said that was because scientists have the same innate curiosity that we usually experience from toddlers and young children. You can tell us 100 times that you really shouldn't do this, but until we actually experiment with it and figure it out ourselves, we will continue to do it. You can, the example that Dr. Goldstein uses is, you can tell a kid not to touch the stove 500 times, but eventually he or she is going to decide to touch the stove at least once, and then they will learn that way, and then they will never do it again. Well, eventually some of us learn our lesson, but we scientists, we just ask questions about everything. There's a quote that's in the commercial that we put together for the department that I use a lot, that says, whenever my students are in lab, I always expect them to have more questions at the end of it than they have answers at the beginning, than they have answers when they're done, because I not only want them to complete the assignment, but then I give them encouragement to think about what extensions they can do to the lab, what would be the next step, and so I get them to think kind of critically and think scientifically about, question everything, and then figure it out later. Scientists are problem solvers. Oftentimes the hardest part about science, though, is figuring out what problem you're actually trying to solve. Because you might be trying to solve a particular problem that's of a global scale, but in order to start solving this global problem, you might need to build something on a very small level and start with something locally, or you might be inventing a small device that has kind of a niche audience, but by the time you've added that in, part in, then it starts to build, and everything builds on everything else. So you start solving a problem piece by piece, and eventually you come up with solutions to larger scale problems. Now, scientists are also resilient and adaptable to various situations, and that's something we share in common with I will say pretty much everyone that I know of that faces medical challenges and medical impairments and challenges is just we are resilient and adaptable. We realize that there will be hurdles that come up. There will be things that we didn't think of. There will be challenges that arise sort of as side effects to the problem that we solved before, and we adjust. We're also extremely driven and passionate about work and about the field that we're in. I am a solar physicist by trade. I got my PhD from looking at the energy spectrum from solar flares. But I've adapted because, let's be honest, it's Coos Bay, Oregon. We don't see the sun enough for there to be for there to be a lot of direct need for observation of the sun from here. But I can still do that through my connections at Goddard, through my connections with friends of mine that work at Southwest Research. We still look at the effects of the sun in some of our projects, and we'll talk about those as we go on. But you always have to kind of stay passionate about the things that you do. I advise all the engineering and physics students, and one of the biggest things I tell them as they're going through their academics is, if you're looking for programs to transfer to and you're looking for potential jobs down the road, make sure you find a job that you're actually passionate about. Because yes, engineering starting salaries can be fairly high, but if you just go into a engineering job for the number of zeros on the paycheck, the amount of work will burn you out very quickly. So you have to find something that you're actually passionate about, and you have to be able to advocate for yourself when you do that. All right. So this is kind of one of the goals and one of the things that we sort of rely on if you're trying to get people into STEM education or into STEM research. This is my story. As a young person, I was determined to be an astronaut, or at least do something space related. Like I said, I got sucked into the whole space thing with Halley's Comet and then just kind of stayed there. I kind of knew what I wanted to do when I was 7 years old and didn't really change much, save for a couple of years when I thought I was going to be a statistician with my local minor league baseball team, just so I could get paid to watch baseball every day. But that was a short-lived thing. Of course, with the NASA astronaut program, there are very specific physical requirements for the astronaut program. There are certain physical health requirements. There are certain benchmarks that you have to meet as far as vision, as far as strength, as far as speed. And I have a vertical leap of 3 postage stamps. I have a 40 time that's timed with a sundial, and I'm not exactly the fastest human being. I'm the fastest human being with reaction times. So I'm not necessarily. So the astronaut program was not going to be one of those things that I could do. But just because I couldn't be an astronaut and float around in space didn't mean that space was not accessible to me. It just meant I had to find another door. And that's exactly what I did. I went to science camps early. I got involved with astronomy clubs in Tulsa. I got involved in science programs early on in K-12. I started taking college classes in my junior and senior year of high school. I then got involved. I stayed involved with local astronomy clubs in Tulsa, where I served as an officer with them while I was finishing my undergraduate. And then I went to Rice University and studied for my master's and my PhD for 5 years down in Houston, Texas. And when I got to Rice, not only was I doing a lot of academic work, but I was also learning how to become a researcher. I had done some research while I was an undergrad, we had worked on a project that was supposed to go onto the space shuttle. Except I graduated in 2003. My senior year, we were supposed to be working on something to go on the space shuttle, except February of my senior year, the space shuttle was no longer an option for a good chunk of time. Those of you that know your historical dates will know that the Space Shuttle Columbia explosion was February 1st of 2003. So it was the spring term of my senior year that I spent that morning basically dodging phone calls because all of the local Tulsa media were trying to find members of our group because they knew we were working on a NASA project, and because we were NASA related and we were tied into Tulsa, all of the local news wanted to talk to us about what had just happened. And we were college students and we really didn't want to do that because it wouldn't seem appropriate. But I did, in the process of going through that and going through the research that we had done, I started to learn what I was good at. And I started to learn ways that I could get involved with space without having to be an astronaut, without having to be the person responsible for building some of the apparatus. With my cerebral palsy, my hand shakes too much, so when I try to do something with really small tolerances, it doesn't work out very well. So what I found that I was really good at was I could design an experiment, I could have other people build it for me, and then I was really good at analyzing the data that came out of it. And as I got to grad school, I started to learn how to code with computers. I started to learn how to move forward with that. And I got to the point where I was analyzing data from 6 different satellites at NASA for part of my PhD, thesis, because I had the ability to take the raw information and process down the information that we needed to feed into models. So that was the kind of things that I was doing, but it kept me close enough to NASA, close enough to space, that I could have an impact in the field that I wanted to without having to leave the ground. So that was my story, but I'm not the only one. I'm not the only one that's gone through that, and I'm not even really, if I want to be honest about it, a lot of the things that I went through and a lot of the things were fairly easy compared to what a lot of the giants that have been in the field that have also suffered through things. And I take inspiration from a lot of these, and hopefully in sharing their stories, they can inspire the rest of you that are watching. But one of my bigger inspirations is Dr. Stephen Hawking, theoretical cosmologist in Britain, studied black holes under Roger Penrose, and then for the first half of his career studied basically how classical gravity worked. And then in the process of initially trying to disprove something that had been suggested about the impact of quantum gravity, he actually discovered what we call Hawking radiation, which says that even though classically no light can escape a black hole can slowly die, because quantum mechanics allows for, if you have light at certain energies, a photon at certain energies can actually do what we call pair create and create an electron and a positron. And if you do that at the edge of a black hole and you conserve momentum as well, one of the particles goes in, but one of the particles gets flung out into space. So essentially, one pair creation particle at a time, a black hole will slowly eat itself to death. Now, this happens over the course of many, many millions of years, but the fact that we see that and we see actual evidence of it indicates that there is a distinct tie between the quantum mechanical realm and our classical understanding of gravity and black holes, which until Stephen Hawking's discovery had not been concretely proven. Now most people know Stephen Hawking because of essentially his prolonged battle with ALS. He suffered with the disorder for 55 years of his life. Was diagnosed with it early in his college years. For the short form version, that is not completely accurate because they did take some artistic liberties, but his wife was responsible for most of the book. If you read the book, The Theory of Everything, or watch the movie, it actually goes through a lot of the steps when he first got diagnosed with ALS. But as I said, I took a lot from him. He's been also one of the more candid and one of the more available physicists in pop culture. You've seen him actually. Those of you that like me, if you're fans of The Simpsons, he's been on The Simpsons as an animated cartoon. He's been on any number of other shows, and he wrote a number of books before his untimely passing. And I was very fortunate to be able to see him actually give a lecture on Pi Day of 2003. That was basically how I spent my entire Pi Day that year. Was the rest of my group was working on a project, but I had my stuff done, so they had put me in charge of, you are going to find us all tickets for that, and then we're going to drive across town. So we did, and that was kind of a life-changing moment for me as well. But Stephen Hawking is not alone, and in fact, some of the other scientists that come to mind that have notable medical challenges go all the way back to the Renaissance. Leonardo da Vinci, noted artist, inventor, scientist, studied geology, studied architecture, known worldwide for his inventions, known worldwide for his paintings, but also known for the fact that many of his writings are actually done in mirror writing, so you can only read them if you basically hold them up to a mirror. They're written backwards. And upon sort of analysis and understanding of his life and some analysis of the types of things that he went through in comparison to what we see today, there's a strong belief that Da Vinci was actually dyslexic. So one of the reasons that he ended up doing some of the mirror writing was as a mechanism to cope with his dyslexia. So if one of the most world-renowned Renaissance men can succeed while battling dyslexia, and if Stephen Hawking can battle ALS for 55 years and discover groundbreaking things on black holes and how the universe actually works, I can definitely sit up here and do all kinds of physics things and inspire and work with students to continue on the legacy. But again, those are not the only ones. Anti-jump cannon, most known for creating or revising really what they call the Harvard classification of stellar systems, which is still in use today. She was also the first female recipient of the Henry Draper Medal. Henry Draper was a famous astronomer and one of the primary founders of the American Astronomical Society. Annie Jump Cannon was the first female officer of the American Astronomical Society. But in addition to all of her findings, she had a severe bout with polio as a child, and it had left her basically 90% deaf. She and one of the other, they called them the Harvard computers. They were essentially scientifically minded female students that, while Harvard wouldn't actually let them into grad school to do actual grad work at the time, this was in the early 1900s, many of them actually, there was a team of them that worked with Dr. Charles Pickering and actually helped with the redesign of the Harvard classification system that we currently use. And although at the time it was done, Pickering got all the credit for it because they weren't willing to share credit with the team that had helped do it. In subsequent and later years, Annie Jump Cannon has gotten a lot of credit for the work that she's done, and there are numerous awards and prizes in astronomy that are named after her and passed on to the high achieving women or high achieving people with disabilities and medical challenges in the field of astronomy. And just to give you an idea what that looks like, this is what's called an HR diagram. It's essentially a diagram that shows how stars appear if we scale them from a temperature scale and what's called a luminosity scale, which is an idea of how much power a star puts out every second. And so if we have a scale, and you'll notice that the lettering is all kind of messed up. There's class O, class B, class A, but they're not in alphabetical order. They started out in alphabetical order, but then after years of looking at various spectra, Cannon and others were able to distinguish specific spectral lines and specific temperatures that corresponded to certain types of stars. So they would look at a star like Rigel, and it would show up as, it would have a spectrum akin to their B model. We look at the sun. The sun is what we call a G2 star. So it is basically in the G class of stars because it has a lot of lines for different metals. The O and B stars are mostly hydrogen with a little bit of helium. The A, F, G, and K stars have a lot more heavy elements and metals like iron in the lines of the spectrum. The M stars are much colder. They're still warm. They're 3,000 degrees, which is still really warm, but the M stars are much colder. They have not only a lot more heavy elements, but they actually start having compounds in their atmosphere. And they also live for an extremely long amount of time, even on stellar classification scales. So when we're able to start classifying stars by their physical characteristics, it gives us an idea of what stars would look like and what to expect from the stars that we see. So I want to talk about other ones. And this is one I actually learned about a month ago. One of the things that NASA has been doing lately in like the last 10 years or so is looking at new ways to process data. And we do a lot of astronomy stuff that is all visual. But when you're doing things that are all visual, there are those that can't take advantage of it because maybe they have a visual impairment, maybe they're colorblind, maybe it's actual visual impairment, maybe it's any number of issues with the eyes. And one of the scientists that comes immediately to mind, and this was partially from an article from the Royal Society, which is the largest scientific organization in Great Britain. Wanda Diaz-Merced, she's an astronomer. She currently works to aid the discovery of black holes through the sonification of large data sets. And sonification means they can take the data set and essentially look for sound wave patterns. You can parse the data. You can actually hear sounds that are coming from the stellar objects that you're looking at. You can hear acoustic waves that are coming off. And Diaz-Merced, she actually started losing her sight when she was a young child, and she always found science and education difficult at that point because, as she put it in the article that I read, she struggled because she couldn't see what the professor was writing on the board, and she could hear everything, but she could hear, but she couldn't necessarily have time to write it down and commit it to memory in terms of notes, and that's why she was always sort of struggling academically. And she began work in science after learning about NASA Goddard's sonification of a coronal mass ejection, which is akin to a solar flare, but it's a larger ejection of solar mass that's controlled by the solar magnetic field. When she got involved with the NASA Goddard project, she found a mentor that was willing to work with her despite the fact that she was behind the curve academically, but she was passionate about making these things accessible to people in her situation, because astronomy is largely a visual science, but not being able to see, she wanted to be able to make the science of astronomy accessible to those with blindness or those with visual impairment. She developed a number of computer algorithms to aid in the sonification of black hole candidate observations, including the one that we've all seen when they did when we did the Event Horizon Telescope, the M87 black hole that I didn't put the picture up here. I promised I wouldn't put the Eye of Sauron back on the screen, but there is an image from the Event Horizon Telescope that they've taken actually an image with radio telescopes and with other means to get an idea of what the radiation field around a black hole candidate actually looks like. And when they did tests with the sonification data and the visual data, they found that having both audio and video helped the scientists identify potential black hole candidates on a much clearer basis than just the visual alone. And we're going to see if this decides to behave. But this is a video from space.com, but this is actually a sonification of that particular black hole. This is the sonification of M87. We'll see if it actually plays, because it does have sound effects, but it's not wanting to play audio, but the whole thing wasn't. Let's see. Is it not wanting to play? I wanted to hear the sound, but I don't know why it's not wanting to play today. Hopefully they can hear it online, and for those of you that are in the audience, when we get done with the talk, if you want, you can come up and I will actually play it, and we'll figure out how to. Yeah, the closed captioning doesn't work very well because it's usually just a lot of it's a lot of fairly creepy sounds, but it's not. But it's not actually. And then another one that I learned about recently, I was looking for scientists and engineers that also, like me, live with cerebral palsy. And this one, Farida Bedwe, she's a software engineer from Ghana. She's a computer programming specialist that works with numerous banks. There's hundreds of banks and financial institutions in Africa and around the world that actually use her coding for data encryption and her cloud-based apps for basically their banking apps for several hundred banks across Africa and across the world, because her encryption mechanisms are able to keep more data for banking customers from falling into the wrong hands. And she's become essentially famous for that, and she has been able to make a difference for not only in computer science and learning different types of encryption mechanisms, but also making a difference in the financial world in growing economies like Ghana and other countries in Africa. So these are ideas of, and these are examples of game changers that have faced similar things with having physical limitations, knowing they have to deal with things, but still finding ways to make global change possible. So I want to look at, this is why I do this talk, is I think about the challenges and I think about how do we solve them. So for me, when I look at it, in my case, it was mostly physical limitations. I have reaction time, speed, balance. I'm slower writing and my hands are shaky. So there are different things with writing things down or construction pieces that it becomes a challenge for me to do. For others, it might be mobility challenges. It might legitimately be that in Stephen Hawking's case, by the time he passed, his ALS had advanced so much that he could basically only move about 3 muscles in his entire body, which is why he had the computerized wheelchair that would essentially speak for him and was essentially connected into his speech pattern. For others, you have mobility challenges. You have some learning challenges. I mean, trying to learn things. Equations are hard enough to learn if you're not trying to battle. Okay, the symbols are in the wrong order, or the symbols don't look right because I can't tell them apart. They're hard enough to learn that way. And then we talk about sensory impairments. I didn't put him on here, but one of the other ones that I could have gone to was Thomas Edison, who was also, as he was making a lot of his scientific discoveries and or borrowing them from other people, Nikola Tesla among others, he was also facing the fact that he was also 90% deaf. So Thomas Edison was deaf, but he was also a known scientist and engineer that was making global change. I just tend to leave him off because I don't like to get too far down the Edison versus Tesla rabbit hole, but that is a discussion I can have later. So, what did I learn from my journey along with the journeys of other people? The biggest thing I can find is find your passion and let it drive you. I told you I was a space cadet from the time I was 5. That didn't change. I had a couple of moments where I had a couple of setbacks and decided, hey, I might want to go just do statistics for the baseball team for the next 20 years and get paid to watch baseball every day. I've had some other interesting things where I was a freelance journalist for writing about music reviews and concert reviews and things, but that was something I did in my free time, but science was always the thing that drove me. And challenges will happen, but they can be overcome with work. You might have to stay late, you might have to work weekends, you might have to add extra time, but you can do these sorts of things. But one of the biggest things I've known about just my own system, and I know it's the same for others in this room that have similar situations, you have to know your own system. You have to learn your own limits. Learn your own limits and don't let those outside limit you artificially. Be aware that stereotypes do still exist, but they're not as prevalent as they used to be. There's a lot more openness toward access. There's a lot more of a push toward making sure that anyone can have access to certain aspects of science and of research. I told you there would be a funny story at one point. I was in 7th grade, and my mom had to advocate for me with the school system because the transportation director was not sure as to why they needed to adjust their bus schedule that was taking me out of my math class 20 minutes early to let me finish my math class, because he wasn't sure why a 7th grade kid with cerebral palsy was in advanced math anyway. So I have seen that happen, and that's one of the things I try to instill in the students and in the educators and community members at large. Don't limit people. If they have a passion for doing things, I was always a math and science kid. my passion was always math and science, so let me excel in that. Don't try to, I realized it was going to make it somewhat difficult for what he wanted to do, but at least let me excel in that. And they finally came to an agreement about 20 minutes after my mom hung up the phone, because I'm convinced had that discussion gone on any longer, I may very well have graduated from a high school named after my mother. but as it was, most importantly, not only do more so than do stereotypes exist, finding support systems are essential. I wouldn't be here if it wasn't for half the people in this room, if it wasn't for a good 20 or 30 people that I won't name all of them because we'll be here forever, back home in Tulsa, and also when I was at Rice, there was a team of scientists. When I was at Goddard, there were a team of people that helped push me along the way. These support systems are essential. I'm not going to say you can't achieve things on your own, but it makes it a lot easier when you have people that are willing to help and people that are willing to support you. So advice for students and for those that are looking at doing research and looking at just doing education in general, find mentors. I wouldn't be where I am today without the guidance of a few people. I said I wasn't going to name them all. I've already named one of them, but I want to at least name three, because the astronomy teacher at Broken Arrow High School, Mr. John Land, was responsible for about 6 years of my life keeping me involved in astronomy. He was also the vice president of the Astronomy Club of Tulsa, and from the time I was 14 years old to the time I left for grad school, he got me involved in the organization, and I was actually rose to the point of being an officer in the organization at the time, by the time I graduated and left. But most of my achievements in astronomy, I draw inspiration from Mr. Land, and I know Crystal has similar experiences because that was one of the teachers that we remember most from high school. Another one was Dr. Jeff Goldstein, who I mentioned before with the scientists are like toddlers quote. At the time I met Dr. Jeff, he was one of the principal scientists that was leading the Smithsonian Air and Space Museum. He's since moved on and started his own 501c3 called the National Center for Earth and Space Science Education, and runs a yearly program that allows K-12 students across the country to design experiments that go up on the International Space Station. They get launched up on the International Space Station, they get run on the space station, and then when the space station gets another cargo refueling ship, they get sent back down so that the students that design the experiment get a chance to actually have hands-on experience analyzing data that came from their experiment that they designed, they built, and they sent to the space station. And of course, I wouldn't have made it through grad school without Dr. David Alexander, who has also given a talk here before. He was my PhD advisor and got me into solar physics. I was not intending to be a solar physicist. It just happened to be, I wanted to do something space related. He had just gotten there like a month before my incoming graduate school class had gotten there. So he had a lot of grants and a lot of projects and was in dire need of students. And he and I sat down for a meeting for about 45 minutes one day. He showed me a lot of cool NASA images of the sun and went, I need somebody to be able to code and analyze these. And 5.5 years of my life, and then the 3 years of my life that I spent at NASA Goddard as a result of it are entirely due to that meeting. So always find mentors. I happened to find 3 that were really good. If you are a community member and you're in a situation where you know of students that are trying to do this, step up and be a mentor for them. It doesn't mean you have to basically tell them what to do. In fact, a lot of cases for mentorship, it was more, go explore this. If you have questions, come back to me. That's kind of the same thing I do with some of my student researchers. Sometimes they're okay with that. Sometimes they would rather I actually just told them what to do. But I like having, but if you're going to mentor somebody, mentor them not only in helping them find the answers, but help them find out the process to find the answer. It's the scientific equivalent of, if you give a man a fish, you feed them for a day. If you teach a man to fish, you feed them for a lifetime. Well, I can tell you some of the answers with regard to astronomy problems and with regard to physics problems, but if I teach you the way to actually solve the problem yourself, then when you get something similar, you won't be stuck and trapped. So the idea is to teach as much that as possible. Search out opportunities. If there are internships available, if there are opportunities to do research at your school, if you're in a K-12 school and you want to get into research that maybe you can do some things after school, reach out to the community, reach out to your teachers. They can connect to other people, which can then allow you to get started. Hands-on experience is always a blessing. You can learn as much from a book as you choose to learn, but more often than not, the perfect problem in the book does not exist in real life. The perfect problem in the book usually has some underlying assumptions that said, we want to do these assumptions to make this problem simpler. But when you get into real life, you will find that there are things that hands-on experience cannot be replaced with. To borrow a song title from the band 8 Stop 7, question everything. Human nature is driven by curiosity, and science is based on those questions. Much like solving problems, the biggest part of anything is finding the right questions to ask. And I borrow this from Reader's Digest. It's a Albert Einstein quote: "Learn from yesterday, live for today, hope for tomorrow. The important thing is not to stop questioning." So regardless of what is going on, always keep an open mind and always stay inquisitive about things. Don't chase normal. This is a mistake I made when I was little. I always, during the early part of my life, I would focus on the things I didn't have or the things that were limitations that I wanted to be like everybody else in my class. I wanted to focus on normal, but don't focus on what everyone says is normal. Embrace what talents you have and find your own normal and find people that support and push you in that direction. And the reason for the graph, I didn't want to go complete math nerd, but I had to do this. All four of these graphs that are on the screen are all normal distributions. They're all considered normal mathematically, just like every one of us in here has a different conception of what is, quote, normal. So in other words, there is no actual normal. There are a bunch of different normals, and we just have to find our normal that makes us happy and makes us successful and work our way through it. And then last piece of advice for the students: come as you are, but expect to grow. Be honest where you start. There may be things that are unavailable to you, but you know your own limits more than anybody else does. A true mentor will meet you where you're at and then push you to go beyond. And somewhere in the room, if he were around, my little brother would be going plus ultra as a My Hero Academia reference. But we need to be honest with ourselves where we start, but find mentors that will allow us to grow and will encourage us to grow. They may challenge us to go look in other directions, but it's not to completely change what we're doing. It's to expand our horizons. Determination and resilience. Setbacks and mistakes will happen. It's not necessarily no, it's just not right now. I told you I spent 5 years working on my PhD thesis. I could have been done in about 4, but there was about a 6-month period where I had to basically rewrite my entire code because I broke it and I couldn't figure out exactly what I did wrong. But when I applied it to new data sets, I couldn't get the right answer. So I had to go in and figure out where exactly in my code my estimations were off. And it took me 6 months of staring at a computer, bashing my head against the wall, and trying to fight through it before I got it. Now, 6 months of not making progress when your entire career has been judged on how much progress you make and how quickly becomes very taxing on one's psyche. But I had friends, I had support, I had mentors that had been there before that had had similar situations, and they were very quick to point out that, like I said, it's not no, it's just not right now. Manage your own expectations. Don't let people do it for you. You are the best guide to what you can achieve. But if you let other people tell you you can't do things, then you kind of hamstring yourself. And then advocacy. Mentors and supporters will help you find your own, will help as time goes on, and they can still help throughout your life, and many people do. And there are people in this room that are very much advocates for me. But over time, you do have to learn to find your own voice and to advocate for yourself, because there will be times when you have to step up and do it on your own. So that's my advice for students, but I have advice for mentors and educators too. Connect and inspire. Connect with students early, and this is where I said we were going to get to see some of the great things that we had, that Crystal and I and the students had done, connecting with one of our local K-12 schools at the Lighthouse School. We were doing rocket launches last Friday. We connect with schools early. We coordinate class visits. We do community events like this one. We do outreach events to the libraries. We go to the schools. We set things up. We do science fair events. We've done science on the boardwalk before. Be accessible for questions. What we don't show you from last Friday was, after we got done shooting all the water rockets off, we basically had a 30-minute panel where a group of very inquisitive third graders decided to pepper us with all kinds of questions, from how to learn about science to different aspects of the solar system, to how fast you had to go to get off the planet, to was Pluto still considered a planet, to any number of other questions. Be accessible to those. And much like the water rockets, make things fun. Kids in particular, and students of all ages, will take interest in an activity if it sticks with them, if it's fun. If you sit there and make them memorize a bunch of equations and make them write a bunch of math problems down, they're probably not going to want you to come back. If you go to their school and you let them build rockets out of soda bottles, and then you launch them into the air with bike pumps, then they're much more interested in having you come back. I think they actually want to come here next time, and they want to attach eggs to parachutes and drop them off of high places and see how well that works. But also, when you start with connecting, this is where the mentorship aspect comes in. If you make contact with people, follow up and stay connected. Don't just assume that they're going to go on and do their own thing. Stay with them. I first met Dr. Jeff Goldstein when I was in 7th grade. He followed me and talked to me pretty much every year when I was in high school. He followed my studies in college. When I got to NASA Goddard, which was literally across town from where his nonprofit was set up, he checked in with me when I was a postdoc at Goddard as well, knowing that he'd had friends that were in the same, or that had brought him to my high school, that kept him up to date on all the things that I had done. So he stayed with me. Mr. Land, that we mentioned before, still checks in with me to this day occasionally. We have, and Dr. Alexander, I can call him at any time and he's aware of what's going on. So if you are going to be a mentor, if you are going to connect to people, make sure to follow up, stay connected, and stay with them, because they can always, it may not be the same situation as before, but you may be of value to them as a guide and as a resource. Mentorship in general. Meet the students where they're at. You're a guide, but allow them ownership of their path. You don't have to tell them, it's like you don't have to tell them what to do. You don't have to tell them where exactly to go. You just have to provide the star map, and they can figure out which constellations they want to aim for. Challenge them. Challenge the students you're mentoring. Challenge the people around you. Challenge them to think, but support what their project or what their priorities might be. You might challenge them to think about something a different way, but in general, you're still going to be supportive of their overall project. Share your opportunities. Share what you know. Help with networking and access. That's why this particular slide is up there. This is actually a snapshot from a meeting that the research group students had with one of my colleagues at Southwest Research Institute, Dr. Roman Gomez, who's been basically mentoring and leading some of us through an understanding of and a study of the interplanetary ion environment using one of the instruments that he helped to calibrate. So we have connections, and we share those connections with the students, and the students learn from actual instrument engineers, instrument designers, and scientists that have experience with those instruments and are trying to understand larger things about our physical universe. But our students here at SWAC, the high school students we deal with, and eventually the K-12 students as they get through here, will have these same types of opportunities. If you have projects, let them get started early. Some of the projects we do, the K-12 students can work through. The community members that are interested could also do some of the same citizen science projects we do. We welcome everybody to start early, to process. I don't need you to be a student here in order to be part of my research team. My goal, and I think our goal as an entire research team, is to get as many people interested and involved in all aspects of science as we can. And again, experience early can reinforce the dream and the excitement that they may have for a particular field. It may also shape where they want to go with their passion in the field. The first thing I ever did physics related was setting up a very complicated optics system for an experiment that was supposed to fly on the space shuttle that needed to have less than millimeter tolerances. Now, I said before, my hand shakes too much, so this is probably not the best idea for something for me to do, but it was a project that needed to be done. I stepped up, I designed it, and then we discovered after I designed it that it was probably best that somebody else build it. But you find out things as you go, and I still learned from that experience, and I learned more about optical systems during that particular 6 months than I probably did the rest of my career. And this is our SPEAR team. Crystal, Caleb, they're both representatives that are here. This is basically a lot of stuff that we've done. This is pictures from us going to K-12 schools. This is pictures of some of the students giving a talk. We do have graduates from the program that have actually graduated from SWAC and transferred on. We've had a number of distinguished lecturers. We've had a number of opportunities to work in the high school and K-12 classrooms to teach the K-12 students how to find micrometeorites, how to look for asteroids, how to do a lot of the different projects that we do. And we look forward to taking all of that and moving forward with it in a number of different ways, one of which is coming in the next few months. We will have our own portable planetarium that will allow for astronomy and other science presentations to go from SWAC around the community, because we have a planetarium that we can essentially blow up with an air pump and allow people to actually sit through various scientific presentations rather than having to go all the way to Portland in OMSI or going to the Science Center in Eugene, which is 4 and 2 hours away respectively. Now we'll have something of a planetarium resource that is right on our doorstep here at SWAC. And finally, for everybody, and I promise I'll stop talking, remember to breathe. Everybody's journey is a unique adventure. Everybody goes in a slightly different direction. Setbacks happen, but we use those as learning experience, not discouragement. Your support system will help you remember that. And I admit that I am guilty as much of getting discouraged by setbacks, but it's often the very people in this room, whether it's Crystal, whether it's Cassie, whether it's students like Caleb, that will point out that I need to remember the good parts of the event and not just the part that may not have gone the way it should be, and use the part that didn't go the way it should be as a learning experience to do better next time. Take time to celebrate the achievements. As you go through, celebrate small victories, and then enjoy the journey as much as you do the milestones. It's not about getting to those mile markers and those milestones. It's about figuring out things along the way. And with that, I will say thank you for you guys putting up with the rantings of a madman physicist, and I hope this was both entertaining and somewhat educational.
One thing I wanted to add, because I don't only get to work with Dr. Coyner, but we've been best friends for years. We grew up in school together. I think I was probably 8 or 9 years old when I met Aaron, and he turned into Doc, and we definitely went different paths in that life. He didn't know all the right things. But watching as his best friend, and we're like family. He referred to his little brother. That's my son. My son Wade's he's 14. I just want to say that times have been definitely challenging because I'm extremely protective, and like people, like he mentioned when he was in school, the very uneducated person in transportation. we came from outside Tulsa, and it was probably one of the nicest schools in that state, one of the largest high schools in the nation. And to think that somebody like that said that not long ago, to show you even more so how much we still have to learn. And we need things like this happening and conversations like this happening. Something that he didn't mention, which is okay, because something that I'm very familiar with is the disabilities that we don't see. It's the mental and emotional disabilities that you don't see for many people as well. There's lots of physical disabilities and lots of different also mental and emotional disabilities. I have personally PTSD. I have severe anxiety. I've had times of depression. And I'm a big advocate on making sure that all the things that we do at all different age levels is accessible and very sensitive to everybody's needs. What is it that we can do to help you and to make sure that people feel that you create your normal, what is normal for you. It's okay because it looks different for everybody. And we're all going to get through it. We're just in different ways. And how can we make this easier? I sometimes walk into a room with the kids and will, when we go see the students at the younger and some of the elementary schools and middle schools and all that. And I can kind of tell some of them that are dealing with some things, maybe anxiety, or maybe we have some like autistic kids and all that. And, we need to make sure that we're very much including all of them. Some of the most amazing people, as you can see, deal with, struggle with these types of things. And they, what I try to remind people is all of the things that we've gone through has just made us stronger. That is for sure. And so, but I want to say how extremely proud, as your best friend, family, colleague, how extremely proud that I am, all of us are, of you, Doc. And I know Wade, he how he feels too. And he would be the same way. And so just thank you for sharing this, and thank all of you and everybody listening online for keeping this conversation happening. Thank you.